Hey guys, it's Rob over at Teeter's Telescopes here in the workshop. Just taking a break to do a quick little informational video on the type of wood joinery that we're using in the construction of our telescopes. A couple telescopes we have behind me here, an 18-inch and we have a 20-inch joining me here in the video. But at any rate, just wanted to go over the types of wood joints just because there's been a little bit of confusion as to the type of joint that we're using, because it looks like one, but it's really something else. Alright, so first let's take a look at the type of wood joint that we're not using. Alright, so let's get that out of the way first. I have a couple pieces of 1/2-inch Baltic birch or Russian birch that have been milled up on our table saw. If you take a look, they're just two plain pieces of plywood, 90-degree corners on them. A butt joint, for those of you that don't know, is simply taking one piece of plywood, putting some glue here on the edge, and then literally, as the title says, butting it up against another piece that we have here to create a 90-degree angle for the corner of a mirror box or rocker box, and then driving some nails or screws through the edge, through one piece and into the other piece. It's a very old type of style for making a box. It's not very strong. Longevity is very low on it. We would never use a type of wood joint like that here in our shop, building our premium Truss-Dobsonian and solid tube Dobsonian telescopes. However, the problem comes in with the type of wood joint that we are using, which we have here. This is a piece, a little cutaway that I put together of one of our mirror boxes or rocker boxes, where you can see the type of joint that we're using. Problem is that it looks just like the butt joint I just showed you. You've got one piece of plywood here, butt up against the second piece to make a 90-degree angle here. Right from the outside, you can see the full width of this, and these are 5/8 inch pieces of plywood, which is actually what we're using in the construction of our telescopes. But if I turn this, we get a little bit closer to the camera, we could see that there's a little bit more going on here in the corner than just a simple butt joint. We call this a tongue and groove joint here. Alright, so let me get another couple pieces of plywood here. Here's a tongue and groove that we have that we can disassemble for purposes of this tutorial. So if we take a look here, we've got a groove. All right, we have a groove routed into this piece of plywood here. All right, we got the groove there, and then a matching tongue in this piece of plywood here. And we can see the tongue on the edge. So what we would do during the construction process is take and slather a bunch of wood glue down through the groove there, and then a bunch of wood glue along the tongue here. And then we'd put them together. And what's nice is that it's a tight enough fit, tight enough machining that the pieces actually do kind of snap together and they push together real nice and tight. We could take a look here, so that's what's actually going on in the corner. Alright, so even though it looks like a butt joint here to here, when you look further inside, it's actually got more glue surface area. And that's really what you're looking for. You're looking for a mechanical connection like we've got here, the tongue going into the groove, but then more area, more surface, more flat surface area that you could put glue on, so that you've got more holding power between the glue and the wood, and then also the mechanical. And as a third part of the equation that we do, we actually drive little brad nails into the edge of the plywood here. And then we do some wood fill, and then by the time we sand it and do sanding sealer and polyurethane and stain and all that, the whole process, the nails just kind of disappear. They're there, but you never even really see them. They just disappear. So between the nails, the glue, and the actual mechanical connection between the tongue and the groove, we feel we found a very good joint that's going to serve us for a very, very long time in the construction of our telescopes. Now, a quick reasoning as to why we settled, alright, I'll say settled on the tongue and groove, is that it's a very economical wood joint to use. Right? It's not going to bog us down in the production process of our telescopes. It's not complex, it's not extremely time-consuming for the amount of strength that you get out of it. So it's a good compromise, I'll say compromise, between strength of the joint versus the amount of time it's going to take us to do the cutting and the assembly to get that joint to go together. So in the end, it's something that we felt is going to serve us well, and will serve you well, actually, as the customer in using the telescope to provide you a piece of equipment that's going to last a very, very, very long time, and that also looks good and performs well. So that's all I have for you guys today. If anyone has any questions, please feel free to call here at the shop or drop us a line by email, and I'd get back to you. I'd love talking shop, and looking forward to hearing from everybody. Okay, thanks a lot. Take care, guys. Bye.